Okay, welcome to Chapter 8, Lesson 4, Surface Area of Cylinders. Our learning target or objective for this lesson is to find the surface area of cylinders. And we do have a couple of vocabulary words. First word is lateral area, the surface area of the three-dimensional figure, excluding the area of the top base, so that the lateral area is the area of the curved surface. We talked about this in class before. If you have a can of ravioli, is basically where the wrapper is, around the middle. That is your lateral area. And as always, you may pause the video to write down your definitions as we will continue on. And the total surface area is the sum of the areas of all of its surfaces, lateral areas, and bases. So when we talk about the total surface area, like if a can of ravioli, we need the lateral area, the wrapper part, plus also the top and the bottom. You have to calculate those as well for total surface area. Let's get on to our next slide, which is our key concept. Our key concept for this lesson is the surface area of a cylinder. First, we have our lateral area. In other words, the lateral area of a area, or LA, of a cylinder with the height h and the radius r is the circumference of the base times the height. So let's write that down. We're going to have to do a little work on this key concept. Write down the formula for lateral area. LA equals, it is 2 times pi times the radius times the height. Okay, make sure you mark those down. Okay, let's go on to total surface area. The words, the surface area, or SA, of a cylinder with a height h and the radius r is the lateral area plus the area of the two circular bases. Okay, we have two different ways we can do this. We have our lateral area, LA, plus 2 times pi r squared. If you notice pi r squared, that is the area of a circle, and usually cylinders, bases are circles. So we're just going to take the area of the circles, and usually they are the same at the top and bottom, so we're just going to multiply it times 2. Or our other option here is we have 2 pi r h plus 2 pi r squared. Same thing, just actually filling in the formula for lateral area on the second one, 2 pi r h. As you see, our base model at the bottom, the big capital B is our base. It goes pi r squared. You have 1 at the bottom and also 1 at the top. That gives us our 2 here in our formulas. And then we have our lateral area, which is in between here and all around. That's where the wrapper would go for the ravioli or chicken noodle soup or whatever kind of can or cylinder that you got. Okay, let's get on to some examples for surface area. Find the surface area of the cylinder round to the nearest tenth. Okay, we need to find the surface area of the cylinder. Okay, first of all, as I always say, is write down the formula first. So we got SA, surface area, equals 2 pi RH plus 2 pi r squared. Okay, then we fill in what is given to us. Okay, once again, we have 2 times, because as you see in the first part of this, 2 pi RH, we have no plus signs, we have no minus signs, we have no division signs. So when they're all together like that, means we're going to be multiplying the first part. So we're going to multiply 2 times pi, which is 3.14, times our radius. Our radius is given as 2, times 2, times our height, which is 7. And now we do have a plus sign, so we're going to add that. We have 2 times our pi, 3.14, times our radius, which again is 2, squared. Okay, if you punch that in your calculator, 2 times 3.14 times 2 times 7 plus 2 times 3.14 times 2 squared, you are going to get an answer of about 113.1 meters squared. Once again, it's about because we do have pi in our formula, so it's about that answer. It's not a given for certain. It's about 113.1 as we round pi to 3.14. Okay, let's move on to our next example, which is a real world example. Circular fence that is 2 feet high is to be built around the outside of a carousel. The distance from the center of the carousel to the edge of the fence will be 35 feet. What is the area of the fencing material that is needed to make the fence around the carousel? Okay, so what are we looking for? We're looking for around the carousel, so we're going to be looking for, they're only going to fence in around it. They're not going to fence in on top or the bottom. So we're just going to be looking for the lateral area of the fencing. So let's, first of all, let's put down our formula for lateral area. Lateral area, or LA, equals 2 pi RH. And we're going to fill in with what we got here. Oh, we got 2 times pi, which is 3.14, times our radius, which is the distance from the center of the carousel to the edge of the fence. So let's imagine a carousel, and then the fencing going around it. It says from the center out, 35, and that looks like a radius to me, so we're going to go with the radius, that is 35. And as it says, the fence is going to be 2 feet high, times 2. So punch that into your calculator, 2 times 3.14 times 35 times 2, and we're going to get an answer about 439.8 feet square of fencing that is going to be needed to go around the carousel. Okay, this does it for our examples for this lesson. Any questions? We may review the examples or write down any questions you have and bring them into class tomorrow.